going to be on the test?
Well, on the test will be the normal distribution and confidence intervals.
Okay.
Okay.
Sounds easy.
We did a few Z and T tests. We identified which was which. And so far we are on this one on the review. It's a Z interval. Let's see, is somebody trying to try? No. Let me line Jordan.
All right, I'm about to put it on mute and get my stuff and then sit down and do this work.
All right, so we left off. We are finding the confidence interval. We already calculated the error using our error formula for a Z confidence interval. Sigma is known. Jordan didn't get an invite apparently. Take care of that. The password. Yes, I invited you twice. I'll just do that and you can zoom in. Okay. So we calculated the error. This should be an 8. And we're going to take our mean, our sample mean, and subtract and add that error value. That's going to be our confidence interval. See here. So on the Casio, I did already calculate the error. And I believe I saved it as A. I did. So that's what I'm going to use. I'm not going to round it. I'm going to actually use that whole decimal the calculator has. 327 minus A. That's the lower end of my confidence interval. The rounding rules, if you remember, you go to whatever place X bar has. If you have statistics, if you have data, you go one place further. So if you had a list of numbers and they were all to the 1st place, we go to the 10th place. Here we're given X bar is 327, so we're going to round this to 295. We go with the same place value as our sample mean. So I'm going to change this from a minus to a plus, and that'll give me my upper limit, 259. And that right there would be the confidence interval. Okay. So first thing you want to do is write down all your information. Make sure you pay close attention to whether it's a sigma or an S, so you know if it's a Z or a T. And let's read the next one. An industrial designer wants to determine the average amount of time it takes an adult to assemble an easy to assemble toy. 55 times, that's N. You get an average of 38.2 minutes with a sample standard deviation, so it tells you sample, of 6.43. It does not give us the population standard deviation, so we've got to use a T interval. It wants a 95% confidence interval, so confidence level is 90, I said 95, 90%.
Hold up, Swallow. Can you restart? Because my internet kicked me out and I missed all that.
Okay, well, I basically read the problem.
Okay. So that's a T interval because of the S?
Yep, it's going to be a T interval.
Okay, does that change the way we approach anything?
Yes, we're going to use the T chart instead of the Z chart.
Okay, well, I haven't been able to watch the video because of the internet. So that's why I'm kind of confused right now.
Well, this is from like 2 weeks back whenever we did confidence intervals.
Okay, yeah, that's why I remembered what to do with the T and the Z. Okay. And then I can't get my chart because the internet's down, so I can't pull up my chart off the internet.
Yeah.
All right, I'm listening.
All right, so we found N, X bar, S, and confidence level from the problem. There's X bar, there's S, 90% confidence level. So with a confidence interval, we need to make sure we do alpha over 2. Jordan. My AirPods are dying, of course. Anyway, alpha over 2 would be 0.05. So T, so we're doing, if we look at the chart for T's, it's slightly different than the chart for Z's. It gives you the area in 2 tails or the area in 1 tail. So you have a choice here. You can either look up alpha, which would be 0.1, in the 2 tail section, because it's a 2 tail, because it's a confidence interval. We got both ways we're going. Or you can look up alpha over 2 in the 1 tail section. Oh, hey, look, it's the same spot. So either way you do it, it's fine. It's still going to give you this column. Just don't look up alpha over 2 in the 2 tail section, because that's a different thing. Okay, so the T critical value is based on the area, the alpha value, and there you are, and also our degrees of freedom. So we look, our degrees of freedom are calculated by taking 1 away from N. So we do N minus 1 for 54 degrees of freedom. So we look up down here, that's in the way. 54 isn't here. So we're going to go to the next closest thing, 55. Again, you can use alpha 0.1 in a 2 tail or alpha of 0.05 in a 1 tail. It's the same column. It's this column right here. However you want to do it, it's perfectly fine with me. So I need to look up the second to last column. My degrees of freedom would be 54. We don't have 54, so we get the closest value. So 1.673 would be my critical value. So if we look at our formula, up here it is. So we're not dealing with a Z, we're dealing with a T. So this is what we need to use. I'm going to calculate the error. That's my T critical value right there. That's my T score, my T value, whatever you want to call it, it's all the same. It's this number right here is that number right there. So let me do a different color. Error is going to be this number times S over square root of n. So I'm going to type that in and see what pops out. TI users, of course, you can just type all this into the T interval and it'll spit out the whole answer for you. Mode 1. I got that 1.673 from the chart. $1.45. And let's, oh, we lost Jordan. Well, 1.45. Oh, there he goes. 1.4505. Why not? And again, we're going to round our final answer to the same place as X bar. So these extra decimals aren't going to make too terribly much of a difference. So 38.2, so we're going to round to the 10th place as the final answer. This is E, though. We don't round back. So for not rounding purposes, I'm going to store that as A. So this is now stored as A in my calculator, so I can go back and just use X bar, 38.2, minus A. That's my lower bound, 36.7. One decimal place here, one decimal place in our answer, 36.7. And if I change that to a plus, 39.7. We should get the same thing on the TI. It actually might be slightly different because of our T value right there. Maybe a 10th place. Probably not, though. Number 8, we have statistics, 38.2. This is T interval. S is 6.43. N is 55, and the confidence level of 90. And we get, okay, same thing, 36.7 and 39.7. If we compare, they're really, they're the same. That little bit of rounding difference didn't change anything at the end. And that's the confidence level for T's, Z's, and P's. So you have one of each of those, and I think we have one more. Do I not? No, there it is. So we just did this one. The next on the list is this one. For some reason, I don't have these copied. That's strange. I'm going to grab these real quick, sorry. So we got a few more problems to look at. Okay, this one gives us data. We're constructing a confidence interval. So again, either calculator you have, you can just type this data in and it'll give you the relevant information. So let's see what we got going on. We've got 14 for n. You could also count them. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got 12. Okay, that's weird. Yeah, huh. So that's 12, not 14. Sorry, weird, but okay. Did I copy something wrong? And Joe Bear plopped out again. Oh well. So n is 12 if we count them. The population is nowhere distributed, and the standard deviation is known to be, okay, they tell us the standard deviation is known to be 10. That makes this a Z interval. confidence level is 99%. So for z's, if we're doing it without a TI, we need to look at the alpha over 2. That's 0.01 divided by 2, so that's 0.005. How we get that is 1 minus 0.99 divided by 2, and that's this 0.005. But we don't have X bar or, and we don't need F. So we need to calculate X bar though. You can type all these in your list and then find the mean that way, or you can just add them up and divide by 12 since there's 12 and not 14 of them. Your choice. I'll go ahead and just type it in the list. Go to mode number 3, number 1, type it in. And there's 12 numbers. Again, I don't know why it's only 12 numbers and it should be 14, but that is what it is. So let's work with it. Hit AC. And we're still in the stats menu, you can see right here. So I'm gonna go to Shift 1, bar. I need X bar. I'll go ahead and store that for later in case I need it. 137.8. That's the data is rounded to the 1st place. I need to round my mean to the 10th place, 137.8. However, whenever I'm doing calculations, I'm going to use all these digits I can. So now we're going to use our formula, this one. So the error, that's a weird E, is Z of alpha over 2 times, if we look, it's sigma over square root of n. Sigma over square root of n. So let me calculate Z of alpha over 2. Your choice of inverse norm or the chart. And I'll start with inverse norm and see how different it might be. 0.005, and I get 2.575, well, 2.576. Looking on the chart, where are you? Looking on the chart, oops, that's the positives, let me go to the negatives. 0.005 corresponds to 2.575. Pretty close. Let me use a 2.575. The TI will give us the other value in a minute so we can compare those. All right, so we got Z of alpha over 2, we got sigma, we got n, we can shove it all in there. And let's see what that spits out. Mode 1, 2.575 times a fraction 10 over square root of 12 gives me 7.4 blah blah blah. I already have X bar saved as A, so I'm going to store this as B. Shift so B, and I'll do 7.4. But again, I'm not going to type in 7.4 in the calculator. I'm going to use the letter B. I have A is saved as this value, and B is saved as this value. That way I can use them to get my confidence interval without any rounding until the very, very end. So X bar minus E and X bar plus E, that's what we need. So that's A minus B, 130.4. Again, our data goes to the ones place, so our interval needs to go to the 10th place, 130.4. Oh. Jared said, isn't it? Keeps saying, yes, I know. He's said so many times. Hopefully you can watch the video before Monday. And 145.3 for my upper bound. So this is the 99% confidence interval for this data set here. And we'll go to the next one. Oh wait, TI, you can use TI, that's what I was forgetting. So it is a Z interval, that's number 7. We don't have stats, we have data. So we need to go type in that data. Stat, edit. Go to the top, clear it, enter. Let's type that mess in there. 144, 14, oh, that's not one. 145, dang it. 121, 148, 150, 134, 138, 135, 149, 37, 123, 130. Initial numbers. So hopefully I didn't mess any of them up. Stat, test, number 7. Select the data option. 10 is our sigma, our population standard deviation. It's in list 1. Frequency is always 1 for this class. That's a 99% confidence level. Now we're going to calculate that as 130.4 and 145.3. Oh, hey, look, it's the same. So even with those slight rounding issues because of the Z-score and all that good stuff, we get the same value. So it's not that big of a difference. I do have like a 10th place error on either side in case you mess up. Okay, look at the next one. We have this one. I believe we have one more after this. Yeah, the sample size. So this is a stem plot. Some of you didn't know how to read the stem plot last time. This is not the number 1, 4, 4. That's the number 21, 24, and 24. Yes, I'm looking at you, Jordan. Let me know if you start not hearing me because I think my AirPods are dying. So I'm just going to do this on one calculator to save a little bit of time. The stem plot below lists all the ages of applicants, given the population is normally distributed, assume sample, simple random sample, 95% confidence interval, estimate the mean. I don't know sigma, that makes this a T. So I need to construct a T interval for this thing. I'll go ahead and just do that. It's actually a lot faster for me to type in the TI, so let me do that. So I'll use the TI to get the mean and standard deviation, but you could do the same thing on the Casio. Just type it in your list and go to the bars, and number 2 and 4 are the mean and standard deviation. So 21, 20, not 21 again, 24, 24, 25, 27, 30, 32, 32, 33, 33, 33, 34, 34, 41, 44, 44, 46, 46, 46, 47. And there are 20 numbers. 1, 2, 3, 4, 5, 10, 15, 16, 17, 18, 19, 20. Yeah, we're good. So let me get out of there. Second mode to quit. Stat test T interval number 8. We do have data. We want the 95% confidence level. I'm going to calculate. And it takes a second. So this is my answer, but what I really wanted from here was X bar and S. X bar is 33.3. S is 10.7. Let me go a few decimal places more just to have less of a rounding issue. 727, let's go. Okay, and our confidence level again was 95%. That gives us an alpha of 0.05 in 2 tails. Chop that in half if we want 1 tail. It's a T, doesn't really matter. Let me go look up, let's see, we had N was 20. That makes my degrees of freedom 19. So let me go look up that T value. See, this is the chi-square chart. We go 20 to 19. We're looking in this row. Area in 2 tails is 0.05. That's that middle column here, right here. 19 degrees of freedom. Area in 2 tails is 0.05. T is going to be 2.093. So my error, basically the same formula as a Z, except with the T in there instead of the Z score. 2.093. And instead of sigma, we have to use S, 10.727, divided by the square root of N, of course. That's a 2 if you can't read my writing. This thing right here looks terrible. Anyway, let's find out what that is. 2.093 times 10.727. Ideally, if I had done all this on the Casio, I would have stored that S value instead of rounding it. But for time's sake, we're just going to round to 3 decimal places. It shouldn't make too much of a difference. 5.02. However, I will store this one. Okay. So X bar minus our mean. X bar is 33.3. Gives me 28.3. And plus our mean, or X bar plus our error, 38.3. And let's see how different that was without the rounding. Okay. So rounding to the 3 decimal places didn't change our value. We still got the same 10th place. Still staying at the 10th place, 28.3, 38.3. So we're good. That's the confidence interval. Again, just type all this data, that's 21, not 1, into your list. Get the standard deviation and the mean from that list. If you don't know how to do that on a Casio, we did that earlier in the video. It's the same place as the mean, just vars 4 instead of vars 2. I can show you where that's at. So you go to shift, stat, var, and there's your X bar and your S. I said mode 1. Okay. Last question. Calculating sample size. propose blah, 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 using social media. How many US adolescents must be surveyed? So N is the question, how many? So N is the question. A terrible question mark. In order to be 95% confident. So that's my confidence level. And error is given to be 5 percentage points. So that's 0.05. Well, let's look at our formula sheet. Okay, somewhere in here. There. Sample size determination. There's 2 different ones for a P sample size, and that's what this is a P sample size. You could have any of these. You could have a P with without P hat known. You could have a P with P hat known, or you might have a mean sample size. They all work the exact same way, just different formulas. So here's the formulas we're going to choose from, because it's talking about the percentage. So percentage is a proportion. That means we're dealing with a P sample size. It doesn't give me any other sort of indication, so we're going to use this 0.25 here. That comes from assuming P and Q are equally likely, which gives us the biggest N value anyway. So this is the most people we'd have to survey. There's no matter what P hat or Q hat actually are, there wouldn't be a less N value. So just type in the numbers. V of alpha over 2. So we're going to do alpha over 2 is 0.025. Confidence level is 95%. 1 minus that, cut in half, is 0.025. Z of that, you can use an inverse norm or the TI or the Casio. Mode distribution, number 3, just an inverse normal of that 0.025. Standard deviation and mean are left alone. We get 1.96. If you're using the chart, look on the chart for 0.025, and we should get, right here it is. You may or may not get an exact value, just use whatever it's closest to, 1.96 right here. Same thing we got on the calculator. So easy enough. And it's going to be 1.96 squared, get a little squared there, don't forget it, times 0.25, because we don't know what P hat is, so we're just going to put 0.25 there. Again, you might know what P hat is, so you'd have to use this formula. And error is 0.05, and don't forget to square it. If we just type that in the calculator, we'll get our answer. And we come up with 384.16. Remember, unless we get an integer here, or a whole number really, we always have to round up to 385. The minimum 384 wouldn't be enough to be certain. We have to go more than 384, and we can't have 1600ths of a person. So, go 385. Boom, done. Okay, that's that. So we went over a couple of the homework problems and test 3 review, the whole thing. Did anyone have any questions? Okay, guess, oh, we got something. Nope. Okay, I guess I'll go ahead and stop recording.